All right. So, hello everybody, and welcome to the stream. Tonight we have an extra night of streaming, and we are going to try and resolve some of the issues that we kind of ran into last night. I have some ideas about troubleshooting that, and hopefully we can get to the bottom of the issue. Before we jump into that, just want to do a couple of quick things. I do want to first and foremost thank the supporters of the channel. Starting with the partners, these are the highest tier of supporters on Patreon and YouTube. That is Caden Parker, Arslia, Gerbolis Inc., Paul S., Super Awesome, and Wensheng. I'd also like to thank all of the other supporters here on the screen. They are supporters of the channel as well, financially at least. And I would also like to take a quick moment to thank each and every one of you who is following along with the series, whether it's on Twitch or on YouTube. I really appreciate your guys' support and your interaction and following along with the series. I appreciate each and every one of you guys being here, so thank you for that. With all of that said, I do also want to mention that this is an interactive stream, so for those of you who are here and now on the stream, if you have any questions, feel free to pop those into the chat below, and I will keep an eye on that and answer them to the best of my ability. Let me just move this camera over a little bit. And for those of you who are on YouTube, feel free to, if you're watching the archive of this, feel free to drop any questions that you have in the comments on the YouTube video. There is, of course, always the Discord. There is a link on the Twitch page as well as the YouTube page, so that should be there. Should you guys have any questions? All right. So, just to kind of catch us up to where we were last night. So we basically were doing a bunch of work behind our scene loading and unloading. And at least on the surface level, it seems to be working. So I can press L here on my keyboard and we load up the scene and everything comes in, streams in just fine. And we can move around and whatnot. And I can hit U to unload that stuff. And seemingly it unloads okay. We do actually have a couple of issues here. But the minute that we actually go to load the scene back up again, we get a crash. And more or less what's happening here is we are, if we take a look at this object here, the geometry itself has been stood up, right? It has a generation. It is seemingly loaded. It has its extents. It doesn't have a name in this case, but that might be just because it's maybe the geometry itself doesn't have a name in the actual file we've loaded. However, if we take a look at the material, this is where the problem arises. So the material has an invalid ID, an invalid generation, and an invalid internal ID. If we look at it a little further, the name is empty. The texture maps are all empty. The diffuse color is black, right? Like this looks like zeroed out memory minus everything that's been set to invalid ID, which is all these numbers here. So I think that the issue may have something to do with the material not being released properly. It's the only thing I can think of off the top of my head. So we're going to sort of drill into that a little bit. The other thing that is kind of giving away some problems with this is when we unload, we are getting Vulkan buffer free requires valid buffer and a non-zero size. So that's a little bit suspicious, as well as this bit here about the Vulkan renderer shader release instance resources failed to free range from render buffer. Now, I tend to think that these are probably both the same thing, but that is actually, I think, where I'm probably going to start tonight, so we can at least resolve those issues. So what I'm going to do to find this, and one of the reasons that I output such verbose messages is because I can copy and search for them. And we have right here in our renderer front end. So I'm going to put a breakpoint right here. And I'm going to run the application again. Right, so load. That's fine. Unload. And here we go. So it looks like we do have our buffer, right? It's a uniform. That's apparently the issue. So it does look like a valid buffer. It's got a memory block and all that stuff, so that's good. The size, however, is in fact 0, and the offset is 0. So what I'll do is go ahead and have a look at our call stack here and see if I can't figure out where this is coming from. So we're releasing a shader instance, which actually might wind up being our problem, because this is what the materials actually use, right? So this may actually be where the problem is. So we have the UBO stride for the shader. And this is the sky. Oh, interesting. I wasn't expecting it to be the skybox shader. Okay, so it looks like the skybox is not unloading correctly. So the skybox UBO stride is 0, which is quite interesting. We'll have to look into why that is. That is probably going to be the entire issue, right? So this is going to be releasing the instance resources. Let's just go a little bit further up here, right? So we have skybox unload. Skybox shader is here. Sure enough, its UBO size is 0. Its UBO size stride is 0. That could be because of the types of uniforms we actually use. So let's see, where did we actually set up those uniforms? Those are going to be, we'll do it this way. We'll search for wherever this is. So skybox, so this is the shader, that's where we actually create the skybox. Let's see. So when we unload it, that's not what I want. This is what I'm looking for. So we have 2 globals and 1 instance, but it's only a sampler. So that's the problem, right? So the instance, okay, so that is actually a bug. So what we basically did not take into account here, if I just go back to where we are in our call stack rather, so right here where we are doing our size and we're throwing an error here, we should never even really be getting to this point, right? Let me silence my Discord because that is making annoying noises. Okay, so where we are actually doing the render buffer free, let's see. Release instance resources. This is probably where we should check for it. Okay, so the render buffer, uniform buffer has a size of 128. All right, so what I'm thinking here is if we do not have a UBO stride, then we should probably not be doing this step at all. Because that means that we don't actually have anything to release from here, right? So if this is 0, right, I could just say not there, but let's be a little bit more explicit. If that's 0, or if it's not 0 rather, then we want to do that, right? Otherwise, we should be skipping that step. So that might be part of it. Okay. So we'll run again, we'll load up, we'll unload. Okay, and that resolved that first issue. It looks like we're also failing to remove a point light, which is kind of interesting. I'm not 100% sure where that is, but we'll look. Let's see. I'm going to pronounce your name Thorgis. I'm not sure if that's right. Hey Hey, reloading was awesome. I really like your architecture design. What kind of impact does the multi-library layout have on optimizing over a monolithic design? So there are some drawbacks to doing it. Obviously, you have the whole indirection thing that happens, dealing with function pointers instead of calling direct functions. So there is that, but other than that, it's really relatively minimal compared to, the other things that we're doing in the engine that are going to definitely take a lot more processing time. It's something that a lot of the big engines do, where the engine itself is a DLL, and then the application just references that. So it's kind of a common design. It's certainly not going to be a performance bottleneck, if that's what you mean. Okay, so we have loaded, unloaded. I'm going to load again. I suspect we're going to hit that issue again. Yep. So it didn't solve that. But before we move on to this, I actually want to solve this issue. So, for some reason, we are getting an error here where we're failing to remove a point light. I'm not 100% sure why that is, but let's go ahead and check that out. So run the application, we'll load up, and then we'll unload. And what index are we at? 2. So I guess the question is, why did this fail to remove? Because it does look like it has valid data. Let's actually look at that first. So I'll go over here, put that, and this is going to be 2. Oh, that's a null pointer. And interesting. So we have 3 lights. Let's remove the first 2, but the third one's a null pointer. Actually, is it? Yeah, it is. So that's interesting. Don't we add them? I'm just going to redo this one more time. I'm going to step into that on the 3rd iteration of that. So I'm just loading up, unloading. All right, so that's the 1st, 2nd, and the 3rd one I'm going to step in. And of course, we have not light, so that returns false. All right. But why then does this report that we actually have 3? So I guess we need to look at add point light. I suspect we probably did something wrong here. All right, so I guess I'll just put a breakpoint. You know what? I'll put it up here just in case. So I'll relaunch the application. It will load. All right, so we're adding our first light. Right, so we push that, return true. All right, so here's our second light. We push that, return true. Here's our third light. And it's valid at this point, right? So if I go here to load main scene, we do have this set up. It is accessing index 2. So yeah, I don't see anything wrong with this so far. Okay. So we will add that. and I think the P lights is, yep, so we have a slot here, right? So we'll loop through this on the third iteration. We should have assignment. We do. So that looks correct, right? Everything is copied over. That's fine. So we've added it. We push our point lights here. And our point lights 2 here is valid. So when we go to unload, oh, I know what's happening. I'm a dummy. That's what's happening. I think I have a suspicion that maybe something with this pop at is wrong. So let's actually look at this entire array. Let's say it is, let's say it's 10 elements long. Okay, well, for one thing, it's not all full of empties, which is, it looks like it's full of rubbish. Which I'm not 100% sure why that is. These top 3 are valid. This third one is null. All right, so let's set a breakpoint here when we go to remove the point lights. Okay, so we've loaded up. We're going to unload now. So simple scene, remove point light. We are going to get a light count, which is this scene point lights. We're going to loop through, try and remove the point light from there. We'll pop this out, right? And let's actually go to the debug console and do darray length. And we'll pass in scene point lights. Oops. Darray length, oh, that's because it's a macro. It needs to be this. All right, so let's do that. So we have 2, right? All right, so it did shorten the length of the array, which is good. So we've done that. Simple scene, remove point light. Again, we take the length here, we have 2. So it's not that one, it's the second one. So we remove that. We pop that. Let's go ahead and take a look at that again. That is 1, so we are correctly doing that one. And wait a minute, what happened? Right, step into that. Now why did that? I must have stepped over it. I bet it's the light system not doing it correctly then. Failed to upload, unload, remove point light. Because it failed here. Something tells me we did something wrong in the array somewhere. So this is just failing because we're getting a null pointer, right? From this guy. But otherwise, we are popping at the index So we should only be popping if it matches, right? So we should be popping at that index. Start at 0, work our way towards light count, which is here. Interesting, interesting. I'm going to restart this and debug in a little bit more detail. All right, so load. All right, unload. So when we remove this, light system remove point, get the state, look through the p lights, so state p lights. So we have 3. Okay, so if they're equal, then we just zero it out. So we zeroed out that first one. Okay, return true. That's successful. Darray pop at, return true. So all we should be doing is obtaining pointers at this for lights at this point and removing them. So scene point lights 10. So here we go. So we have index 1. All right. And then the state p lights here, it's going to knock out the second one. No, it knocked out the third one. Let's skip the second one. Interesting. So I would think they'd be removed in the same order that they were technically added in, just because of the way that they're added to the list, but that's not the case. Because it removes index 0 and then we removed index 2. But then scene point lights were popping at index 1, which is this guy. And that did not modify whatsoever. So I'm thinking our darray pop at is just wrong somehow. All right, let's have a look at this real quick and see if we can't figure out where. So this definitely seems to be where the problem is. Where else are we using this, by the way? Simple scene, events, when we unregister for stuff, okay? In the console, when we unregister a command. So not very widely used. So we first get the length and the stride from the array. If the index is greater than or equal to the length, then it's outside the bounds of the array. We're not hitting that. So we get the address of the array. Let's see, what's destination? Right, so we copy out to this pointer here when we pop. So we copy what we're popping out. So that's going to be the address plus the index that we're popping times stride. So that's going to put it at the right place in the array. And then we have stride. So we're copying that out. Then we have if not on the last element, snip out the entry and copy the rest inward. So basically what this should be doing is starting at the index, which is here, copying from the next index over times, so for the next index over, so we're copying inward by 1. And then we are, let's see, doing the it's going to be length minus index. I wonder if that's just off by 1. Counting up, pop at 0 shifts everything back. By the time you get to 2, it's already empty. Yeah, I'm thinking there's something stupid I've missed here for sure. But I mean, technically speaking, it should be... Let me run through this in my head real quick. So the length minus the index is going to give us the remainder that we have, right? So it actually, shouldn't that be minus 1? I'm thinking that should be minus 1. Length of the array minus the index minus 1. I'm not 100% sure that's right. But if we have, let's say, you're saying counting up. Which counting up or counting backwards shouldn't actually matter, should it? In this case, just because... Oh, wait a minute. We are... I think I see. Simple C. All right, so I think I see what you're saying. Right, because we're popping out of the... We have to restart. Yeah, okay, there's nothing wrong with pop at. Pop at is fine. Apparently logic escapes me tonight. Okay, so yeah, the issue is we're basically pulling an index that would have already been popped. So yeah, I now understand what you're trying to tell me. So instead of doing it this way, we should probably just be... I guess we could just look at index 0, right? Well, yeah, it's not even this that's doing it. It's this guy that's doing it. If we always remove index 0 and and we do that forplight count, technically that should give us what we need, because it should move it in every single time. So I'm going to remove these breakpoints and run this. Load. Oops, get rid of this. All right, unload. Yeah. Get rid of these. Get rid of that. Yeah, and what do you know? It works. Okay. All right, so that issue is solved. I don't think, though, that that's going to solve our loading issue. So I think this is something else. So I think what we have here is a case of just a material that's not getting disposed of correctly. So I'm going to go into the material system. And where we're doing all this reference counting, I'm actually going to put another method in here to dump all of the materials that are in the system, so that when we unload, I can see what materials are actually left. So I'll just do it here. Void material system dump. Right, and I'll put this after apply local. And we will take a look at the registered material table. So to refresh our memory on this, the registered material table is a hash table, and it holds material references. So the hash table block of memory that is in that is basically just an array of material references. So between that and the actual count of the elements that we have, we can just loop through that and have a look at all of the references, right? So we have a material reference array, refs, we'll call it. And we can basically just cold cast this to an array because that's what we know it is under the hood. And then for u32i equals 0, I is less than state pointer registered material table element count plus I. And then we can take a look at the material reference itself. So I'm going to grab a pointer to that by taking the address of actually refs sub I. And then if our let's say reference count is greater than 0, or I'm also going to look at the handle if it's not invalid ID, that either one of those things could technically be construed as the material still existing. So in this case, I'm going to do, I guess I could do a K debug. Found material ref. We're going to put the handle and then ref count, right? So %u / %u r handle r ref count, right? And I suppose we could even attempt to get the material name. So if state pointer registered materials, and then we have our handle, we should say if our handle is not equal to invalid ID, and right, because we may hit this block because of one of these things or the other, so we should double check this. So if the handle is not an invalid ID, then we'll take a look at it and get the name of the material. Actually, yeah, that's all I'm going to do here. So I'll say k trace, just so it's a different level. Material name. We'll put the name there, right? And then we'll have to go into our testbed main, and we're just going to jam some test code in here. Let's do update. We'll do it right here. To temp. We'll say if input key was input was key down, and we'll say key R, and input is key down, key to R. Wait, if not key down was key there, not if was key down, but if key is down, meaning it was just pressed. Then we are going to do material system dump, and we probably do not have that included, so we'll go up here, and I'll just jam it in here. Include systems material system. All right, let's build that and see what we get. Here we go. So if I press R, the only thing we have is test UI material. So we'll go ahead and load. And now we should see basically a whole crap ton of them, right? So we have all these materials and ref counts, and whatnot. So that makes sense. And then we'll unload. And then we will do R one more time. And interesting. Okay. I think I found the problem. So, all these materials have handles in a single ref count. But the materials have been wiped out. In every case except for test UI material. Interesting. Okay, so that actually does tell us something, and it's likely the root of the issue. So if we have a handle and we have a ref count, then that means we can actually pull a material out of the reference materials or the register materials. That is technically exactly what we're seeing. So that does make sense. The question is, why would we be getting a single reference on all of these? So I guess let's look at the material system release. And we'll just walk through this logic real quick, because there's probably something here that's not quite happening correctly. So first off, if we have the default material name, which is just default, we boot out of that because we never want to release that one. We get a material reference. So we say, hey, hash table, do we have a material by this name? Give me the reference entry for that. We immediately say, if it is a reference count of 0, then we consider that a non-existent material. Otherwise, if we're not booting out because of that, we're not actually seeing that error anywhere, we go ahead and decrement the reference count. If the reference count at that point is 0, and we are auto-releasing. Oh, that's interesting. Maybe we're not auto-releasing. Then we go ahead and get a pointer to the material using the reference handle. we go ahead and we destroy the material. So if we peek definition on that, destroying material is basically taking a look at the textures, releasing those textures, which is consistent with what we're seeing. We release the texture map resources, again, consistent with what we're seeing. We release the renderer resources, which is the shader instance stuff. So we zero it out, the material, and then we set these things to invalid IDs, which is all of this is consistent with what we're seeing. These are all U32s, so I don't think we have any wrapping issues. Nope. So that is consistent with what we're seeing. So it's not that. The next thing is we set the ref handle. So we set the handle to invalid ID. And then we set auto release to false. And then we update the entry. Register material table, name, reference. I'm not seeing anything. That immediately is giving me the idea that, okay, let me go ahead and reactivate this trace stuff here so that we can see that. So we will build and run. All right, so we'll load and we will unload. Looks like, okay, so we can see oh, interesting. Okay, I think I see the problem. So if we look at some of these here, actually we'll look at this last one as an example. So we're counting down on this column C, right? 9, 8, 7, 6, 5, 4, 3, 2, 1. And then all of a sudden, we have an unnamed material here that gets released because the reference count is 0 and the auto release is true. So what does that mean? More than likely what's happening is the name that's being passed here is probably owned elsewhere, or maybe owned by the material itself. And the issue is that that string is getting destroyed before we actually update this. So the string is basically an empty string at that point, and it's saying, hey, update the hash table entry for empty string, and then set it to this reference, which is why we're not actually losing or completely obliterating our entries in the hash table. So I vaguely remember hitting this issue once before, but I have a feeling it might have been in the texture system. Because I could have swore that we actually dealt with this once before. So in this case, we have like this process texture reference thing that we use. But if we are releasing, yeah, see, we have name copy here. Where is this? Right here. Yep. So we actually ran into this problem a long time ago in the texture system, and we now have it in the material system. We've always had it in the material system. We just never saw it till now. So when we go to release, before we destroy the material, which probably means realistically, we can do, let's see, we want to use name copy, right? So we're just going to always use name copy, I think. So right here, if we pass this check, we're just going to go ahead and take a copy of the name, right? Since it would be wiped out if destroyed, as past name is generally a pointer to the actual materials. Should have fixed this in both spots, but I guess material name max length. All right, so now we have name copy. You can come down here and instead of using name, we'll use name copy. Whoops. Copy. And I think that's actually going to fix our bug. So let's build. All right, and run. And did I actually shut this down last time? Let me make sure. All right, so we'll go ahead and load up the scene. All right, and we will unload the scene. See, that's still sus because it's saying release material empty string. So, release material, oh, right. That's because this should also be using name copy. So let me just fix this in here. These should both be using, oh wait, this one can't use name copy. This has to use name, I think. No, it has name copy. Okay. So our logging there should be using that as well. Okay. And this one can just use name because it doesn't need name copy because nothing happened. All right, so I think that was just a bug in the logging, but we might as well fix that too. So load, unload. All right, and I'll just move this out of the way. And if you have a look here, we now see that we're correctly updating our material reference. And since we have the correct name, I'm pretty sure it's correctly updated. So now if I load again, there we go. Problem solved. So that is awesome. All right. Okay, so I think that took me a little bit longer than I was hoping to fix, but hopefully the debugging experience was good for you guys. Hopefully you kind of learn how we solve those types of issues, right? I'm going to turn back off this trace stuff here. Let me just have a quick look at all of my changes here. What changed in the Vulkan backend? That was a good change. We need to keep that one. Oh, I need to undo. Yeah, I'm going to take this out because we don't need this anymore. I'm going to take this test code out. Because we don't need that. I will leave the dump function here. Dumps all of the registered materials and their reference counts handles. All right. Let's see. Okay, so that's that. The material system, I think the only thing we did was fix that bug. Our ktrace messages, we kind of updated those so they're correct now. The hash table set is correct. And the material dump, we are going to go ahead and keep that for right now. And then in simple scene, we just dump the first light every single time. So let me actually go into this. Let's see. Always kill the first one on the list each time since entries are popped from the array. Okay, bugs fixed. So I'm going to make sure we're on the right branch here and commit this because we are in a good state to move on to the next part of the feature. TNT Master, hey, you're late. Yeah, that's no big deal, man. You always say you're late, but it's no big deal. You know, these will be uploaded to YouTube, so anything you missed, it'll be there. OS Smudge, or is it OSmudge? OSmudge. I'll go with OSmudge. Yeah, don't worry about being late. You basically just missed me debugging some issues, so I fixed the various console errors that we were having with unloading the scene, particularly removing the point lights. We were trying to free some instance data in the skybox shader that didn't exist. So that was another one of the errors. And then we also fixed the issue of being able to load and unload and load again. So we now have the ability to do that. All right. So fixed unloading issues, material reference bug, and light system removal bug. I'm not picky, but I go by Smudge where available, and OSmudge is a backup. Perfect. All right, that's what I'll roll with then. I'll say Smudge. All right. So let me push this. Cool. All right, so now we can actually kind of move on to the next thing that I wanted to sort of get started on, which is also kind of part of this feature. So I think I might, you know what? This is stable though. Let me go ahead and merge this. Let me go ahead and merge this so that you guys actually have it on the main branch. There's no real reason not to. So we have a whole bunch of stuff here. This is basically everything that we've done in the branch, which is quite a lot at this point. So I'm just going to do a pull request. Here's the commits. There we go. I'm not going to delete the branch though, because we're going to continue working there, and we'll just merge into main as we go. All right. With that, the next thing that I want to talk about is I want to talk about the scene configuration, because we have mentioned in the simple scene that we have the ability to configure it, right? And that's generally where this kicks in, right? Where we have hierarchy between objects, and where we have the ability to sort of, we should have the ability to sort of script out our scenes. Now, there's two main points that I want to bring up, some requirements. The first requirement is that there has to be a human readable version, right? Because we don't have an editor yet. With that said, we also need a version of it that's going to work with an editor. And generally speaking, we want something that's going to be relatively fast to load, which means not parsing text. But that also goes against having a human readable version that we can write out in a notepad or something like that. So what we probably are going to do is do this in a couple phases, where we will have a scene configuration that starts off as just a human readable text file. And we can sort of compile that scene when we get ready to ship it into some sort of a binary format that we make up. And at that point, when you go to ship the game, you just ship it with that file and not the human readable text file. But with that, there are other requirements that come into play as well. So I think, did I have, let's see, I did have a document on this. So let's take a look at our scene notes here. So we've actually done a good portion of things here. We don't have a generic scene interface yet, but we've more or less defined it by this, right? So eventually we can sort of, we can set this up and then just point it to our simple scene, if I decide I want to do that in the first place. So our simple scene adds and removes renderable types directly, add mesh, skybox, light, etc. Remove. Okay. We decided we were going to skip this. Pointers to renderables are stored in an internal list for each type. That's done. Should have its own file format with nestable objects. This should be traversed in depth first order to ensure proper parenting of sim objects. Sim object is basically kind of what we're referring to as, and we're saying we're skipping that for now. It's basically the renderable object combined with a transform is ultimately what we're saying at the moment anyway. And we are going to be extending this to do various things, but again, it's a simple scene. We don't want to add too much to it, right? So we're not going to be implementing any sort of ECS or any ability to decorate components or anything like that with our simple scene. Our simple scene is meant to just be that. The pointers are meant to be sort of owned by something else. We should be able to actually, here's one that I forgot actually. There is something we need to add. We need the ability to get a pointer to an object by name. That is an important one, right? We're going to need that actually after we get this configuration stuff in place. But the important part is we're going to need some way to set these up and be able to nest them to one another. Adds. We will be right back. All right. So, what we're going to need is the ability to basically define a format and then have the ability to reference objects by one another. And I think the simplest way to do that is probably by name. So, I think for right now, what we're going to do is we're probably going to implement the name portion of this. We should probably do that first. So, when we go into simple scene, if we take a look at what a simple scene actually has, it has a directional light, which does not have a name. It has a point light, which does not have a name, right? If we take a look at that. It has a mesh, which does not have a name. Now, I think the mesh config technically might have a name. It has a resource name, but it's not a name, right? It's not an object name. Oh, pending mesh. You know what? Pending mesh, I think. That's another thing I'm not sure I'm going to implement for right now. So we're going to ignore that. And then the skybox, of course, doesn't have a name either. So that means that we need some way to include these things like in a named type of format, right? And I'm thinking the simplest way to do that is probably going to be where we add these individual things. We go ahead and put a name in here as well, so that whenever we add these things, we have a name to associate with what we're passing in. And then internally, we can associate that within, say, a hash table or something like that. And then, we can just sort of iterate from there. So that is where I'm going to start, because we need that functionality before we can really do anything else, before we can even discuss what the scene format might look like. So we'll say const character name, and we're just going to add that to all of these. Right. Oops. Go into the C file here. Whoops. Wait a minute. Why did that? Why did it pull up that one? VS Code, you are special sometimes. All right. So directional lights. Meborn, thank you so much for the resub. 2 months. I really appreciate that. Thank you so much. I appreciate your support. Missed the last couple, but awesome to see you start getting into the scene system. Kohi's systems are starting to take shape. Yes, they are. So our scene system right now is actually operational, more or less. It's just we need to actually set it up so that we can actually configure this stuff by file and not by code. So that's kind of what we're starting to work on now. We have the ability to load and unload scenes. Since you missed, the last couple, I'll go ahead and do a quick recap for you here. Let me build these real quick and fix the issues that come up, and then I'll kind of show you where we're at. Right, so I just need to add a name to these things. I don't know, I'll call it Skybox. It's a terrible name for it, but whatever. Next thing is going to be these errors are kind of hard to see, actually. Let's just do simple scene add. That way they all get highlighted. Okay. So we're adding a mesh. We're going to call this test cube 0 for this one. We'll call this next one test cube 1. And then this one, test cube 2. Let's see. So the Falcon, we're just going to call that Falcon. The Sponza, we are going to call that, surprisingly, Sponza. The directional light, we'll call that Sun. The point lights, we'll call this point light 0. And then point light 1, 2, and we should be good there. What am I missing here? All right, let me build. All right, so that change doesn't do anything yet, but just to catch you up where you've missed the last couple of streams, we now have this load main scene in our testbed main. This basically goes and creates a simple scene, and then we can go ahead and create a skybox. We add the skybox to the simple scene. We create a mesh. This is an example of how to do it in code. And then this is how we go ahead and create the mesh, and then we add the mesh. So this is an example of how to do it in code. So we do that a couple of times because we have our 3 test cubes, right? And then we have our Falcon, which we're actually loading from a file. So we use a resource name to do that. And so we create the mesh, and then we add it to the scene, and we give it a transform. We do the same thing with the Sponza. We also have a collection of lights here. So we have a directional light where we add that. And then we have 3 point lights that we add to the scene. And then we say initialize the scene. And then we kick off the loading of the scene. So some of these steps are kind of combined right now, but that's more or less what we do. And so every time we hit L on the keyboard, we go ahead and we load up this scene. Every time we hit U on the keyboard, we unload the scene. So if I run this, we start off with no scene loaded, and then I press L and we load up the scene. And then once that's done loading, we can unload the scene, and it's unloaded. And then I can press L again and load up the scene again and unload it again, right? So we do have the capability to do that now. So now that we have that, the next logical step is to go ahead and configure this to work with files. But it sort of dawned on me that if we're going to be able to create a file format where we can reference the objects for something such as parenting, which is probably the only thing we're really going to allow references for in a simple scene, we need a way to reference them. And we could go with some sort of ID, but I think the easiest way is a name, right? So the name just needs to be unique, but I think that's more than reasonable. So what I think I'm going to do is I'm going to implement a super naive way of doing this because it's a simple scene. I'm not looking to make this the most performant or the most robust thing. It is a simple scene after all. And so we have the ability here, when we add things, we assign a name to it. And so one of the things that we'll do on the way in is verify that that name doesn't exist for anything else. And then we'll also have to add some functions to get these various objects by name. So the objects, the names, I guess, will have to be, technically they only need to be unique for the type of object that they are, just because of the way that simple scenes work. I may enforce that they need to be just unique across the board, but I think for right now, I'll just probably have maps of each individual object. So with that, probably the best way to do this is going to be to use a hash map, I'm thinking. Let's see, when an editor GUI is in place and you add a new object, render, etc., the default tag would need to be unique, and the GUI would have to be tracking that in the background versus default or box or something. Yes, exactly. So probably what I would do for that is just generate a GUID, right? And assign the GUID, like the string version of the GUID, to the object name. And that should be guaranteed to be unique. It's probably the way I'm going to get around that. The other way I suppose I could do it is keep an internal counter, and then say like new object 0, and then 1, and then 2, and then even if we destroy objects, we never decrement the counter. And so every time we create a new object, we just increment the counter, and then it's just, new object X. If we use a 64-bit int, you're never gonna overflow that, right? unless you're just creating and destroying objects like crazy, right? But that shouldn't probably be doing that anyway. Okay. So, we have remove and add. I think what I'm going to do is I'm going to say simple scene directional light get. Do I want to say by name? That seems kind of verbose. Should be kind of obvious. Seems kind of obvious, but instead of a B8, I'm just going to return a pointer. Simple scene directional light get. I think that's fine. I'm going to do the same thing for point light. So point light get mesh get and skybox get. And then obviously if it doesn't find it, I'll just return a null pointer. Yeah, I think that works. That's simple enough. So we'll go just below remove skybox and we'll put it here. Obviously we don't need the KPIs, KAPIs rather. So for this, if not seen, return 0. Otherwise, we'll return scene directional light. And if that happens to be a null pointer, so be it. The reason I'm doing it this way in this case is because there's only ever going to be one of them. So I guess it doesn't really matter what the name is. I guess I could match the name anyways and then just return a null pointer if the name doesn't match, but I don't know if there's really any point to doing that. Like, I think I could just literally do it this way. I'm going to do the same thing with the skybox. So actually, this is just going to change to SB. Oops, not DB, SB. Again, I don't really think I need to worry about the name here. I just put that in there so the API is consistent, and if I decide to change the implementation of it behind the scenes later, I can do that. All right, so the get by name here is going to be extremely simple. I'm literally going to do a U32 length on scene point lights. Yep. And this is going to be D array length. And then iterate U32 I equals 0. I is less than length plus I. And then if string, oops, I need to include, let's do it up here with the other core ones, include core k string, string, I could do equal I, but I think I want to keep it case sensitive. But I am going to use n equal, because I feel like having stupidly long names is kind of stupid. So I'm going to say name, and then scene point lights. Oh, you know what? We're not actually storing the name yet. What am I doing? Yeah, this is gonna be point light names, right? So to do point light names, right? But this is literally all it's gonna be. Is we're going to loop through each one of these and literally check if the name matches and then return. We could do a hash table for this, which might save us a little bit of time if we have like a massive list of objects, and that might be the way I do it going forward. But our hash table implementation is a little bit lacking, so I kind of want to add a faster hash table before I do that. This is full of coffee, by the way, so just in case you're wondering. All right, so I guess we need to look at the add here. So add directional light, I'm just going to ignore the name for now. I'm going to ignore the name for skybox as well, since we're not using it to look anything up. I guess what I could do is literally just have an array of names. And whenever I modify this array of meshes, I could modify the array of mesh names. Let's keep it simple. So let's do a type def struct we'll call this mesh lookup, and this is going to have a const character name. And we might expand this later, which is why I'm putting it into a structure, because we may want to do something a little bit fancier later on, but for right now, this is what we're going to use. So we have struct mesh lookup, mesh lookups, array of mesh lookups. And I suppose, actually, let's do this a little bit smarter. We'll do U32 index. Right, we'll keep the index there. That way we can use that directly to... I don't know if I want to do that, actually. Because if we pop at, that's going to mess everything up. Let's not do that. Let's not. That'd certainly be a more robust way, but it's going to require us to write more code to get this up and running. And we're not going for robust here, we're going for simple. So we have mesh lookups, and then we'll also have point light lookups, which is basically the same thing, right? So this is going to be point light lookups, array of point light lookups. All right, so now we have our lookups. We should probably go into simple scene and set those things up as arrays. So let's see, where do we create those? We create those here. So out scene point light lookups equals array create point light lookup. All right, and we're going to do mesh lookups. So we'll create that. And then whenever we go to add a point light, we'll start that one first. We'll array push scene point light lookups, and the value is going to be point light lookup and then we'll say lookup dot name equals string duplicate name, right? That way we don't have to worry about the lifecycle of name. And then we can put lookup here, okay? So that's pushed into there. We should probably also do the same thing for mesh. So we will do right here, mesh lookup. We'll zero it out for good measure, just in case we ever change the structure. We'll say lookup dot name equals string duplicate name, and then darray push scene mesh lookups, and we will push in lookup. Okay. So now we have the lookups. Give me 1 second. I just need to close my office door. All right. So we have our lookups. The other thing that we're going to need to do with our what is it? Remove is for our point light removal. We are also going to have to pop the lookup. So darray pop at scene point light lookups. We want index I, and we need point light lookup rubbish2, right? And then we'll pass the address of rubbish2. Right, we don't really care about what happens there. We just need to make sure that that gets popped out of the array. So I'm actually going to copy this. Actually, I don't even need to do that. Remove point light. Remove mesh. What are we doing in unload if we're not removing the mesh? We need actual unload. So we remove the directional light here, but so that's how we handle point lights. What about meshes? Where do we actually, so we're just mesh unloading these. Okay, so we're gonna actually have to handle a couple things here, because I didn't realize we hadn't actually implemented remove mesh or remove skybox. Sweet. So I guess with remove skybox, that's going to be basically the same as directional light. I'm going to treat it the same, so I'm just going to do this and change all the light references to SB. Cannot remove skybox. I'm seeing that that is not part of, wait, what? From a scene of which it is not a part. Wow, awkward English there. Okay. Skybox. Whoops. Skybox. We don't need to do this. And SB equals 0. Okay. So there's that. The mesh probably needs to be handled a bit like the point light. So I'm going to do this because we didn't actually handle this, which we should have. So M. This is going to be mesh count. This is going to be meshes. Meshes equals M. We don't need to do this. We do need to do mesh unload M. I think that returns a Boolean, so we need to check that. Okay, error. Failed to remove, or no, failed to unload mesh. And this, we should probably, do we want to return false there? Yeah, I guess we could. Just to indicate that there's some sort of problem there. And this is going to be mesh rubbish, right? So this is going to be meshes. And then this is going to be mesh lookup. This is going to be mesh lookups. Okay, so that should be good. All right. Why is this saying there's so many errors here? What am I missing? Oh, that has an identifier there, which makes me think the header file might actually have the same thing. Did I foobar my copy pastas here? Yes, I did. I left the identifiers in here. What a dingus. So that's what I get for copy pasta. All right. So okay, yeah, that's just bleating because that's not returning anything. And same with this one. Okay. We should probably look at the actual unload before we move on. So mesh count. Let's also do we'll loop through this separately. U32 mesh lookup count equals the array length. Scene mesh lookups. I'm just going to copy pasta this because I don't feel like retyping the whole thing. Mesh lookup count. If scene mesh lookups sub I name, then we'll get string length of the name, U32 length, and then we can do I still have string free? I'm not sure that I want to use that. No, I'm not going to do that. Okay, free. I want to do this on the name. The size is going to be length plus 1. size of char times length plus 1. Oops. And then mem tag string. Right? So we free that string. And then we should be able to destroy the array. So I'll do here if scene mesh lookups, destroy mesh lookups, and then point light lookups, destroy point light lookups. Okay, so we have mesh lookup count. Let's go through and doplight count and plight lookup count, which is point light lookups. So we'll just replace these things, plight lookup count. That should free all of those. Why am I getting ad breaks 4 times an hour and 4 ads each time? It should only be twice an hour. You might have gotten one when you first came in, maybe just bad timing. But yeah, it should only be once every 30 minutes. But yeah, I think there's like 3 or 4 ads. But anyways, yes. I'll see you later, TNT. Thank you for joining. Appreciate it. All right. So that's our plight lookup count. So that should all be good. So now we can actually do these gets. So we want the point light lookups count. And the point light lookups we want to do sub I and then dot name. So we'll compare those 2 strings. If those are the same, then we will return scene point lights at that index. Otherwise, if we get down here, return 0. Not found. I suppose we could actually warn simple scene does not contain a point light called S. And we'll go with name. All right. So that should be that one. And then the only other one we have to do is right below it. Which, for this one, I'm actually just going to use the same logic, right? So this is just meshes instead. So mesh lookups. Do that. Meshes. And it's not called, great, does not contain a mesh called that. All right. And it looks like we got a couple of issues here. So k-free block. Oh, it's because it's const character. We have to convert this to a void pointer. All right, and looks like we still got a couple things going on here. Oh, right, we didn't provide a length to n equal. I'm going to say 256. We really have a name longer than that. That's kind of sus. So let's go with 256. It's not there. Too few arguments in function call. Did I not? No. This needs to be a void pointer again. Okay. All right. So now that we have that, now we should be able to go ahead and get objects by name. So I think what I'm going to do to test this is I'm going to load up a scene, right? And with this loaded up, I'm going to come into my debug console, and I'm going to say simple scene. I guess we could use, we'll say mesh get. This is going to take the, I think I'm actually going to need a breakpoint for this. So let's go to update. I'll pause right here. Okay. So we need the state main scene. We need the address of that. And then we're going to go for Vulkan. Simple scene mesh get. Did I type that wrong? Simple scene mesh get. Maybe it won't allow me to run it this way. Simple scene. Yep, it takes the scene, it takes Vulkan. I guess I can't do that in the debug console for some reason. It's very strange how some of it works and some of it doesn't. I wonder if it's like the compiler optimized it out or something stupid. That might be it, actually. It might have optimized it out. So let me try. Let me test that theory. So scene, state rather, main scene, want the address of that, and we'll say Vulkan, and then we'll do mesh pointer m equals, and just so it doesn't get optimized away, we'll throw that in here but not do anything. Right? And I'm going to remove this breakpoint. Oh, right, because the simple scene isn't loaded. So we're going to have to wrap this in if state main scene dot state, oops, is equal to simple scene state loaded, then we can do this. Otherwise, that's not going to work. If you guys have any questions, by the way, this is an interactive stream, so feel free to drop them in the comments if you have any questions. All right, so I'll load up my scene. All right, and then I'm going to go back to my debugger and put a breakpoint. And let me see if this works in the debug console now. No information is available for the function being called. Trying to, interesting. Okay, so apparently the debugger can't do that even if I put it in here. Maybe I need to be at this level to do it. Nope. Okay. So some stuff works with the debugger and some stuff doesn't. It's really strange. It might be because I'm calling it from the test bed instead of the actual engine is where I'm trying to do this. So maybe that's it, but let me see if this actually works. So did we get a, yeah, we did get an address. We have a unique ID, we have geometries. So it looks like it did actually return the thing. The config, we don't have a resource name for one. Probably because it got disposed of, actually, now that I think of it. Okay. So, whoops. The geometries, you have like valid material and all that stuff. Yep, test material. Wait, test material. That doesn't seem right. This is supposed to get the Vulkan. I better step into that. So the length of our mesh lookups is 5. How is that? Those aren't equal. What am I missing here? Oh, wow. I'm trading that as a... Sweet. So Stern comp. If they're different, then it'll return a non-zero value. But if they're the same, it'll return 0. So it's actually got my Boolean flipped here. So this is actually an interesting bug that's been here for 11 months. Sweet. We should be checking this against 0. The other ones are, but somehow I guess we've never used that particular function before. Okay. All right, so here's the app. We'll load. So now let's see if we get the correct mesh. We do have the Vulkan. So that's cool. It seems like it's not loaded yet though. So I'm going to let this rip for a little bit. There, now it should be loaded. And yep, okay. So it does look like the get functionality is working, so that is awesome. So I will kill this. All right, so now that we have that in place, now we can actually start thinking about our file format. And it's going to be something that we have to make sure is relatively easy to reference one object to another. So we need the ability to parent our objects to one another. And for that, we should probably take a look at how we're doing things in the main scene. So we basically want our configuration file to kind of read a little bit like this, minus the creation of these cubes, right? We don't necessarily need to do this. Although I suppose we could. So we do the creation of the scene, which all that does is just stand up some basic things in the structure, if that even. Yeah, just like creates the D arrays and stuff like that. And then we start saying, okay, well, we have a skybox, so we need to create the skybox. The skybox has a cube map name of skybox. The skybox has a name of skybox. And then we add that skybox to the scene, right? And then we have the configuration for a cube, right? So here's all the properties of that configuration, and then we create the mesh for that. And then in this case, we assign a transform, and then we add the mesh, right? That's called test cube 0. The second cube, again, we create the configuration, we create the mesh, we set up a transform, but then we do a set parent. And in this case, we actually have pointers to the meshes themselves that we're using, but we're not going to have that in config. So what we're probably going to have to do is we're going to have to set the parent by name and then say, okay, go ahead and get this object by the name and then set the parent of the transform to that parent's transform. But other than that, I don't think that should be too difficult, right? So I think what I might start doing now for tonight, and this will give me some time to think on it as well, is we're going to go into assets and we'll create a new folder and we're going to call this scenes. And I'm going to create a new file and I'm going to call this, I guess I'll call it test scene, and we're going to give it a file extension of simple scene, simple scene maybe, right? And this is going to be the more or less the text version of this, right? So we want to probably define things a bit like some of our other formats. So like our material, let's see, do we have, these are all compiled materials, binary materials. That's probably a bad example. I guess we could look at our shader config, right, as an example. So we just have these properties that we set along the way. We have the ability to add comments, which is great. So I'm thinking something like this might be a good way to start, but also we should also have like header sections, kind of like an INI file if you've ever seen one of those. So what I'm thinking is we might have scene, right? So this declares properties of the scene until you get to something like that. That's like considered a closing tag, I guess you could say. And so we could say maybe name of the scene is, test scene, right? Maybe we have a description for the scene. Maybe that description will be like a simple test scene, right? Maybe we use that in the UI somewhere. And then we can have things like skybox, right? So this is going to tell us we're going to add a skybox. And then we can close that off as well, right? And so in this case, maybe we have cube map equals skybox, which I think is actually I think that's what we're actually using. Cube map name. Let's go with cube map name, right? So we'll say cube map name skybox. There's not really a whole lot else to skybox config, so that is kind of a simple example of an object, right? It doesn't have a transform or anything. Maybe we'll have directional light, right? And then we'll have the closing sequence for that. And our directional lights might have, let's see, let's go down here to that. So directional light has color and direction, right? So I'm just going to copy these two. So we'll say color equals this, and direction equals that, right? And I believe we actually already have, I believe we already actually have something to parse vector 4s like this. And I think we needed to have it space delimited. So we'll get rid of the commas, right? And that's how we define color and direction. And then that's the configuration for that. And we read that in, and it becomes an object that gets added to the scene. For these things, we also probably need to define a name, right? So our name here will equal skybox. Our name here will equal sun, right? Maybe we also have let's see. I guess we could do, so we have a mesh. We have two different ways of creating meshes, right? We have the ability to generate mesh config, and then we also have the ability to load that from a resource name. So I guess let's do the resource name one first. So maybe we have mesh, whoops, right, with a closing thing there. So maybe the name equals Vulkan. Maybe let's just stick to the naming convention here. We'll say resource name equals, what do we have? I think it was Vulkan, right? Yeah, Vulkan. And then we have to find some sort of way for this type of object to have a transform. So there's a couple ways to do this. We could set up the transform as sort of an object of its own, which might make it a little easier to understand. Or if we look at the transform structure itself, we basically have a couple things that we would want to use. So we have a position, a rotation, and a scale. And so we could say you have to define a vector 3 followed by a quaternion followed by a vector 3. We could also maybe have it set up where you use Euler angles instead. So I'll have to think about maybe how we want to approach that, because we could just say maybe you have to say transform equals, and then you have position, right? So it'd be x, y, z, and then qx, qy, qz, qw, and then scale x, scale y, scale z, right? And maybe that's how we enter transforms, and we just basically serialize that straight into the structure. That may be a way that we do it, or maybe we have, maybe we just do a transform, right, within this, right? We have position equals x, y, z, and then rotation equals, this. But maybe we also say rotation equals Euler x, Euler y, and Euler z, and no component, right? So we see, maybe we look at the rotation, we see, okay, if we have 3 components, it's an Euler angle. If we have 4 components, it's a quaternion, right? And then scale is equal to this, right? Maybe something like that. Maybe that makes more sense. Or maybe this is the shorthand form. Maybe we support both, right? Parsing this might get a little bit tricky, though. So I'll have to think about that a little bit. But we would basically just put in the meshes that way. And then if we wanted to say, let's say we also have, let's say we have Sponza, right? So let's put Sponza here. We could also optionally say, well, what if we wanted the Vulkan to be parented to Sponza? Well, then we could maybe say parent equals Sponza. And that would actually make the Sponza mesh the parent of the Vulkan mesh, right? Maybe that's the way we do that. And that's nice and clean, right? So All right. So I think this is probably a good place that we should probably stop. I'm pretty satisfied with where we're at so far. So I'm just going to commit this for right now. Let's see, what all did we do? I think we added names to objects for simple scene. Working on file format design. Okay, and we'll push this. All right. And I'm gonna snooze the ad because I'm basically getting ready to end the stream here. So, all right. So with all that said, I pushed this up to simple scenes now, so we at least have it there. This is kind of the file format I'm thinking of right now. Simple file format for a simple scene, right? And for more robust scenes, we'll definitely have to come up with something more robust than this, right? Probably like a JSON file format or something like that. But for right now, I think this will work perfectly fine. I've got a couple things that I want to think through and work out, mainly this transform and how we want to actually handle that. You know, maybe we do this or something, right? Maybe we do that. I don't know. So I'll have to do some thinking about that. But yeah, I think it was pretty successful tonight. We did a lot of cleaning up and troubleshooting, and our scenes load and unload fine, and we can actually get them by name now, which is awesome. So I am going to pick a channel to raid real quick if there is one. So let me see. Okay, so Pirate Software isn't online, but there is a channel that he started called Ferret Software. And Ferret Software is basically his pet ferrets, and it's a 24/7 stream that runs. So I'm going to raid that just for some relaxing ferret footage, right? Because why not? And yeah, maybe if another game dev is on another time, I'll raid them. But you know, if you guys have any suggestions, feel free to drop them. But yeah, I think that is going to do it for tonight's stream. So thank you guys so much for tuning in. I really appreciate it. If you haven't already, toss me a follow. I greatly appreciate it. Also, don't forget to check the YouTube channel for the archives of all these videos, right? Because I do upload the archives there. So anyways, I'm going to go ahead and end the stream now. So I will see you guys later.